Hey guys, Mrs. Dan's here. Sorry I couldn't be with you today, but we are on lesson 6. If you could just copy the objective. We're still working with similar triangles. Sometimes it will be on a coordinate plane, sometimes not, but definitely to find missing sides, we use proportions. And you're supposed to be doing lesson 6 now. I'll probably wind up doing that with you. I actually would like to go over last night's homework with you as well if we have time. But so let's first do lesson 6 now. So of the triangles listed below, we have to circle all triangles that are similar to triangle ABC. So triangle ABC is already drawn for us. I'm going to put it in red. And we have to find things similar. So they're talking about triangle DEC. DEC looks like it could be, so let's make a proportion to make sure. So my red triangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units high, and 1, 2, 3, 4, 5 units wide. While the green triangle is 1, 2, 3, 4 units high and 2 units wide. If I made a proportion, I could say that the 10 goes with the 4. Is 10, well, actually, let's just look at this for a second, using the rise and run of the triangles. So let's not do 10 over 4. Let's do rise over run, like if we're finding slope. Let's do 10 over 5. And then on the smaller triangle, 4 over 2. And when we look at those cross products, we get that 20 equals 20. So they really are similar. This first one worked. But so instead of doing like I was going to do the 10 over the 4 equals the 5 over 2, I chose to do 10 over 5 because they asked me to use rise and run. Since this is a line, we like to find slope by doing rise over run. And if both triangles have the same rise and run, they wind up being similar. And actually, any right triangle we put on one straight line will have the same rise and run. So is triangle ADG similar to the one that they gave us? ADG does not look similar. Not at all. How about CGF? CGF looks like it could be. It looks like it makes a right triangle on that line that's drawn. The rise is 1, 2, 3, 4, 5, 6. And the run is 1, 2, 3. So again, if I use the original rise over run and compare it to this new rise over run and check out the cross products, I get 30 equals 30. So really, CGF is similar. And then finally, ABF. ABF. It's not a right triangle. I can't do rise over run. That's not similar. So really, the gist of today's lesson is that if you draw a right triangle on a line, you will always have similar triangles. You can draw a large right triangle and a small right triangle, and the rise and the run will be ratios that are in proportion with each other. So Brandon and Madison used different triangles to determine the slope of the line shown. Brandon started at 0, -1. Let's put a point there. And drew a right triangle going up 2 units and to the right 3 units. Yep, he can use that triangle to find the slope because it ends up on that given line as well. So he has a rise of 2 and a run of 3. Madison starts in a different spot. Madison starts at -3, -3. And she's going up 6 units and to the right 9 units. So that can also be used to find the slope of the line. She went up 6 to the right 9. It asks us to draw and label both triangles on the graph, so I drew them. I just have to label them. The first one I drew was for Brandon, and the second one I drew was for Madison. Describe how the two triangles are related. Well, since they're right triangles on a given line, they should be similar. We're going to prove that they're similar by showing Madison's rise over run equals Brandon's triangle using his rise and run. Both these cross products turn out to be 18. So now we're going to use this diagram and we're going to find the slope of the line using points B and C. So I have to use points B and C and do rise and run. It looks like I'm going up 3 to the right 2. So I'd say the slope is 3 over 2. Then it asks us to find the slope using different points. Now we have to use A and D. And I have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3, 4, 5, 6. So I get 9 over 6. It says use the properties of similar triangles to explain why any 2 points on the line can be used to calculate the slope. Well, let's prove first that these slopes are the same. 3 over 2 can't be simplified. That is the simplest form of that fraction. But 9 over 6 can be simplified. 3 divides into both 9 and 6. Therefore, I get 3 over 2, which means no matter which points I use, I get the same slope. So the properties of similar triangles to explain why any 2 points. Well, when I draw a right triangle on the line and I do the rise of the run, I'm really using corresponding sides. In similar triangles, corresponding sides are always in proportion. In the diagram below, triangle ABC is similar, remember the symbol for similar, to triangle ART. They're asking us to find the coordinates of point C. Here's point C. You can see that I don't know the first coordinate, but the second coordinate is 0. It's asking us to justify the answer. Justification in math can be work. So here's what I want you to notice. This looks like one of those figures of a triangle inside of a triangle. So I have this small triangle, and then I have a larger triangle. And they already told me they're similar. Therefore, their sides are in proportion. Remember we had said that we like redrawing these figures separately. So here's my small one. I'm going to label it A, R, T, since that's what it's called over here in the original picture. And the larger one is A, B, C. So here's the hard part, labeling the sides. What are the measurements of the sides of these triangles? So we have to go back over here and look at the coordinates. If I look at my green triangle, and I look at how long that side is, I can see that it's starting at the point 0, 2, and it's going up until it gets to 0, 8. So how many spaces did it hit if I'm going up to 0, 8? So from 0, 2 to 0, 8, it had to go up 6 spaces. And then this bottom piece of the small triangle, if it goes from 0, 2 to 3, 2, it must have gone over 3 spaces. So when we're looking at this horizontal movement, I'm looking from the 0 to the 3, right? That's why it went over 3 spaces. And when I'm looking at this vertical movement, from 2 to 8 means it must have gone up 6 spaces. So I'm going to label this side 6 and this side 3. Now we have to do something similar for the larger triangle. So this bottom piece is what I don't know. It's going from 0, 0 to x, 0. From 0 to x, I have no idea. I guess it's an x. But this whole entire side from 0, 0 to 0, 8 was 8 spaces. So the tall side is 8, the bottom is x, and now we can make a proportion. We can say 6 over 8 equals 3 over x and do our cross products. So 6x equals 24, and when you divide by 6, x equals 4. So if x is 4 and they're asking us to find the coordinate of c, c's coordinates must be 4, 0, and that's the final answer. And you're going to use that information to help you do your do now. So, to help you do your homework. So you can work on your homework. Let's go and I'll answer maybe homework questions that you had from last night's homework when I see you. So enjoy the rest of the day. Do a good job on this homework. I'll tell you that this last question is a bit tricky, so be careful, and I'll see you soon. Bye.